So, let's say you have a 3D model in Godot 4 and you want to create a 3D shader based on the vertex positions. So, you'll need to set the surface material override to a new shader material and create the shader and open that up in the shader editor. And the easiest thing to do is just set the albedo equal to the vertex. So you can see now it's mostly green because the R and the B axis are negative. So they're just set to 0 basically. So the I can go ahead and repeat the colors by setting it to the modulus. So albedo R equals mod albedo R, and I'll just use 1 since it's about a meter tall. That works. So you can see the effect that has, and this will just make it easier for you to see the texture as well. Okay, so we have the quadrant here, the quadrants. Now you can see, but the problem is that it is shifting with the camera, right? Because for whatever reason, the vertex references it's like the camera coordinates. So to get the actual coordinates, vertex, you'll get the inverted view matrix times, and then it has to be a vector 4. So you'll get the vertex and then just add 1 at the end. And I found this on Reddit somewhere. I don't really know how matrix multiplication works. And then that'll be a vector 4, so you just need to get the x, y, and z out of that. So now we are getting the local coordinates instead of the camera coordinates. So that is how you basically get a partially static texture. And so the thing is, though, if you move this at all, it will change the texture. But that's good if you want, like, if you want repeating textures or whatever. So if you want the texture to stay the same no matter what, you can actually get the vertex out of the vertex function here, which is kind of interesting. So you'll just make a new varying vector 3 local vertex, and then you can set the local vertex equal to the vertex in the vertex fragment or the vertex function, and then in the fragment you can instead of using the inverted world matrix, you can set it to the albedo to the local vertex instead. So then what that does is now when you move it along the axis, you can see the texture is not changing. So if you wanted it to be based on the local coordinates instead of the global coordinates, you'll do that instead. So otherwise, the inverted view matrix, you can do that. But the problem here is, regardless of which one you use, whenever you animate it, as you can see, it's still reacting to the actual physical coordinates, right? So there's no way to actually get the rest pose coordinates when the model is animated. So what you have to do is you have to inject the vertex array into the custom 0 array before you run the shader on it, basically. So I'll go ahead and show you that if you want the texture to stay still when it is animated. So if it's a static object, it doesn't really matter, but yeah, so I'll show you how to make it still even when it is animated. So in order to keep the texture static even when the model is animated, for this example, I will just make a tool script, but you can definitely do this in-game as well. So we'll call it a tool, and I'll just make an export variable to update, and then when you set it, call the inject vertices function. So then in the inject vertices function, I will first get the service arrays from the mesh instance. So service get arrays, and this has to be called on the array mesh. And then I'll set the service arrays at mesh custom 0 equal to a packed float 32, and then for index in service arrays at array vertex dot size, I want to, so the values will be stored in a float array, but it is a vector 3, so each, the x, y, and z has to be appended individually. So we'll get the service arrays, the vertex array at I dot x, y, and z, like so. And then I'll need to make a variable for the flags, set it equal to the mesh dot array custom float RGB. So it just needs RGB float. Since you only need 3 values, you can use RGBA for vector 4s, and then use the bitwise operator to set it to custom 0 shift. So this is the flags, and then I'll make a new array mesh, and add a service from the service arrays. It'll be primitive type triangles, service arrays, and both of those are empty, and then set the flags. So there's I think 4 custom channels, 3 or 4. So you can inject more data this way, and it basically aligns with the vertices, with the vertex array. And then I'll set the mesh instance dot mesh equal to the array mesh that I just made. So now whenever I go over here, well, so basically in the code, in the shader, then instead of setting it to the local vertex equal to the vertex constant, you'll set it to the custom 0 constant, and you have to tell it x, y, z because it's a vector 4 for whatever reason. Okay, so there's nothing in the custom viewer right now, right? So it's just black. However, if we go ahead and run that tool, I may need to reopen it. Yeah, so I'll save it, reopen it, and then go ahead and update it. And now as soon as I inject the data, you can see it has colored the character, but whenever it runs, you can see the texture is static. So if you look at the feet, right, you can see that it stays the same color, where before it was changing. So there you have it. This is how you make a completely static 3D shader based on the vertex. So this is how you get the vertex positions in the rest pose. And if you want to use a different pose, you probably just want to set the rest pose. So there you go. I hope that you enjoyed. Please subscribe, share this video out, hit the like button, let me know what your thoughts are, and thank you for watching.